ready to pay attention? Everyone is ready? Do you see whiteboard? Good.
Sir. Yes, sir.
Okay, no problem. We start, guys. Attention. Now we continue doing a little bit about piecewise defined functions. Remember, it's a function, suppose g of x, that we can define in different pieces and different expression que corresponde or associate with a different interval. For example, this example says que one is a constant. So actually, default, you need to understand que es y equal 1, no? Because it's f of x and or g of x, whatever function notation is equal y. If x is less than -1 and x minus 1 squared, if x is in between -1 and +2, and 1/2 x minus 2 if x is greater than 2. So it's one function que is defined using different pieces, different expression, this, and this, and these pieces is valid in the corresponding condition, que is this for 1, this for this, and this for. Well, in order to understand a little bit much better, I propose you do the number line here. This is the number line, negative infinity to positive infinity, 0 in the middle, and the important point is -1. Look, -1 equals -1 here, and +2, no? +1, +2. Okay, this interval is that one. So any value you like inside this interval from negative infinity to 1, -1, no including -1, the expression is just 1, y equals 1. However, the second interval is, let me change the color, maybe blue is good. And this interval gets in between -1 and +2. Okay, in this case, including -1 and including +2, the formula associates y equals x minus 1 squared. Finally, another color, maybe orange is good. And this interval, and this interval no included is this direction, and this is parenthesis. Entonces the expression is y equal 1/2 x minus 2. Let's suppose que in the test I give you different values to evaluate. Evaluate g in -5, please. Evaluate g in 0, please. And evaluate g in 2. Okay, let's do it. So remember, -5 is located here, -2, -3, -4, -5. This is -5. And -5 is located in the yellow interval. And the yellow interval is associated with the piece. Okay, y is equal 1, and the answer is just 1 without do anything. Only selection, and that's it. 0. 0 is here. So it's lie in the blue interval. Okay, guys, 1, 1, 1, 1, 1, 1. Possibility to identification without diagram. This sketch is you, for example, you suppose x equal -5, and plugging in in this inequality, -5 less than -1. This statement is so because it's true. Therefore, you select this. See, you plug it in and another no. So you select the expression number 1. And the 0, well, 0 you evaluate here. 0 is less than or equal -1, or greater than, sorry, and less than or equal to. Again, it's true statement. Entonces now 0 belongs to the blue interval, and you express it, you select the expression que corresponde with this interval, you copy like that, and you evaluate at x equals 0, que es the value that I need to investigate. This is convenience notation. You put this symbol. Remember, this symbol is equivalent mathematical like a source tag. When you put like that, so you put a variable equal something, no? Equal the value that you want to evaluate. In this case, 0. The plugging in is parenthesis 0 minus 1 squared. 0 minus 1 is -1, and -1 is squared por 0. Boom. Finalize. There's a 1 here, 1 here. And let's do it number 2. Number 2 is, wait. Number 2 is confusing because number 2 is here. And number 2 is the boundary, the endpoint que separates the blue and the orange. Entonces I don't know exactly. I know because equal sign bracket is belong to this. So this 2, when you plug it in again here, is -1 less than or equal to less than or equal to. This statement is true, no? It's true because 2 is greater than -1 and 2 is equal to, so not necessarily satisfy. Remember, this symbol is equivalent to say less than or equal to. Entonces es equal to. Entonces less than es obvio que es no true, pero que equal to es true. So at least one statement is true. The compound statement is true. Entonces now you plug it in again. It's exactly the same. X minus 1 squared such that x equal to, plug it in. Parenthesis 2 minus 1 squared. 2 minus 1 is 1. And 1 is squared 1. Wow. By coincidence, the answer and the 3 value is the same. It's a coincidence. It's no. I did artificially to create this elegant 111 answer. Any question? I promise in the review package we go over again to this and we analyze another example, no? Of this. Okay, so now another topic inside the piecewise function. No problema, guys, no problema. Zoom up or zoom down? Come on. Come on, any signal? Okay, zoom up. Okay. Another topic inside the piecewise function is do the graph. So in the test, 1 question or 2 questions is do the graph of the piecewise function. In this case, not too complicated to graph because we have only, 2 pieces, not 3 pieces. So, and the problem is do the graph is 3 pieces. Suppose I bring 2 examples. I want to explain both. Use by hand, do it by hand, and using decimus. You say by hand, no technology, and using decimus. Okay. And don't try to do anything in Desmos now, because I will send the Desmos script when the class is over with the YouTube video. I send to you the script of Desmos. Okay, suppose the first example. Do the graph. Number 1. The function is called f of x. The function is defined only for 2 pieces. It's -3 plus x if x is less than 1. And 4 is a constant function. This is a linear function. The second piece is a constant function if x is greater than or equal. Let me try. I have my rectangular coordinate system by hand. I know Desmos so far. Okay. Here I take the first piece. Is this. So I suppose the y is equal to -3 plus x, or more elegant, you know, is x minus 3. Entonces me dice, linear function es linear. Y I know que the format for the linear function is mx plus b. Okay, compare this and this. It's obvious that m is 1, slow is 1, and b is negative 3. You know, b represents the y intercept. It's the point when this line crosses the y-axis. So we have one point here, que es 0,3. And plot 0, -3, sorry. And the slope is 1. And remember, the slope definition is rise is a ratio between two quantities, rise and wrong. So it's equal to 1 is because both rise and wrong is the same. So you move up because it's positive to the right, and 1 to the upward, sorry, and 1 to the right, and you obtain the second point. Okay, so using the rule to connect in this point, 45 degrees, but in the opposite direction. -45 degrees. For the opposite direction. And you are doing, let me use and recolor this one. How do you get your coordinate? Okay. Repetition again. Somebody asked me how you get the coordinate. Okay. Do you understand this point? Yes or no? 0,3. I plot that, no? You understand this point?
Can you explain
yes
how
or
you
no?
The zero coming at you?
Because a B, okay, B represent always y intercept. Y intercept is the point when the line crosses the y-axis. Si crosses the y-axis, and the point que crosses the y-axis, x is 0. 0, B. Pero B in our specific example is -3. I plot that. On the other hand, I have the slope, and the slope is 1. If the slope is 1, it's because our line increasing from left to right upward. So it's increasing function. Entonces, rise is that segment, and wrong is this segment. And this allows me to determine the second point. Que the second point is the point 1, -2. 1, -2. You can check it if you want. Okay, that point below or not to the line. Okay, let me try. 1 here, plugging in 1 here, 1 -3 is -2. Good. I have 2 points connected by the straight line and the story. Entonces, now this line represents the first piece, that one, que es -3 plus x. Okay? Okay. Let's do in the second. The second is 4. The second piece. You do the graph independent, separately. 4. And 1 of 4 is a y equal 4. I know that y equal 4 is a horizontal line. Y equal 4 is a horizontal line passing through 4. Passing through 4. 1, 2, 3, 4 here, over there. Now it's a line horizontal. Horizontal means 0 degree. It's low 0. 0, 0, 0, 0. 0 degree. And we are doing the line passing through 4. Because I know that the y is set the 4. Okay. And this is my second piece, que is y equal 4. Okay. Now, the transition. What is the transition? Well, the transition is the point in which the piecewise function change. Okay, I know the change in positive one. How do you know that? Because look at that. The conditional is 1 less than and greater than or equal. So my transition is located in 1. 1 is here. Let me use in blue color. 1. Entonces this is vertical line because it's x equal 1. X equal 1 represent vertical line. Entonces I use my rule 90 degrees. 90 degree, 90 degree, 90 degree, 90 degree, 90 degree. No. And 1. But in this case, this is auxiliary construction. Therefore, I put dotted line because this dotted line help me to understand that we have two semi-plane. So our original plane is split into semi-plane. This is to the left, it's obvious, because it's less than 1. And this is to the right, include 1. Okay? Therefore, what is my final answer? My final answer is, okay, to the left is valid the linear equation is this. So therefore, we coming from the negative infinity to this point. Oh, touch. But in this moment, immediately jump to another condition, que es the horizontal line, que es this, and continue forward. Okay, the answer que I want is the purple color, no? Or the pink color, purple color, que I put very bold highlight. I finished, no, not yet, almost I finished. So now I indicate what's going on exactly in the transition point. In the transition point, I can see that we have here a hole, and we have here no hole, circle full. What is the reason? Okay, this is full, and this is hole, empty. Bueno, when they say it no equal, it's empty. Sorry, I make a mistake. I did completely backward. Okay, no. This is full because it's equal and 4 is the line, and this is empty. And this is important detail. I need to see that. Okay, I need to see that. I need to see, and the rest, if you want, you can erase that part. This was auxiliary construction. Okay, don't need. And the dotted line is also don't need. Not necessary. Okay. It's important to say something. Notice that we have one circle full, one circle empty. Could be both professor, both empty or both full? Yes and no. So both empty is possible. Like that. Not in this example. Not in this example. However, two full, no. Because two full is no function, because remember the definition for the function 1x is associated with the one value of the y. So you have full is because 1x corresponding to value of the y. It's a contradiction for the function. So in the 99% of the case, we have one circle get full circle, and another is empty. Okay, indicate case defined only in the full, not in the empty. It's exactly the same idea of this. Equal sign, full. No equal sign, empty. Any question? Graph of the piecewise function by hand. To say, I propose you do again this problem, but using decimals. I prepare for you this example. Don't only take a look. No, don't do anything. Don't copy anything. Well, copy the thing you want, no, but It's not important. O sea, it's because I want to send the script for you when the class is over. Entonces you open at home. Entonces remember, it's the screen que I send to you as a copy. You can modify, erase, delete. Doesn't affect my work. Let me try. It's here, over there. Piecewise. Switching to decimals. Let me know si you see or no decimals. Do you see?
Yes.
Okay, look at that. I here create example 1. Example 1, I create 2 folder. When you expand the folder, you see the equation. Look. Okay, entonces the way to indicate condition in decimal is, look at that, you copy y equal -3 plus x. You open this curly bracket and you put a condition. Okay, look. You put here. Okay, look. This is the line, que es the red color. Look. Let me put unenable, unenable. This is the piece que corresponde with the line. This is the piece que corresponde with the constant function, y equal 4. And super important, the point. This point is full and this point is empty. How you change that in decimals? Well, easy. Let me show you. Make it zoom to see more clear. You click on this icon, you hold the mouse, and you change. Look here, empty, full, or cross. Cross is not necessary in this part. Or empty, or full. Okay. Now this is the piecewise function. Do you understand or no?
Yes.
Okay, let's do one more example. But in this case, I want to do in decimal only, not by hand. Okay, the second example, okay, is this. Doing in demo look tricky. No, Mr. Holmes, no, it's easy. It's technology. Either way, I explained both ways. You are living in the free country. You got it. Okay. You need to practice maybe, but I don't want noise. You have to option. Suppose you are living in the jungle. Okay, you are doing by hand everything, no problem. You are living in the United States of America, 21st century. We have internet. We have a special software like Decimals. It's a fantastic, beautiful, fantastic graphic calculator online. You don't need to download anything, and you create the account and save your work in the cloud. This is fantastic. Okay, suppose this example in which you have that piece. Look. Bueno, no. You have this piece, que es y equal x squared. It's a parabola. Pero parabola in between -2 and +2. It's a -2 and +2. The point are, suppose this one. Okay? And the label associated is -2,4 and +2,4. And we have another piece, que is a line. Look, it's a line. After this, for x greater than 2, it's a line. And what happened in the connection? And well, in the connection we have here the empty circle. Full here is defined that point, and empty here. Okay? And the label, you want to put the label, in this case is 2,3. Okay, so this piecewise function, I want to come back again to the whiteboard. I don't want to do by hand. No. So now, guys, listen to me. Suppose that you solving the problem in the test like that, and you click here, look at that, share the graphic with the professor in the test, and you export the graphic, boom, like that. Zoom 100%, medium, whatever, bold, not too much. It's either way, the way you prefer, and you download this image, and you send me back. End of story. Download. Wow. Any question? Any question? Any question? Any question? Okay, let me try. Come back again to the whiteboard. Okay. Share screen. Switching whiteboard. Okay. Let me know if you see or no the whiteboard now. You see whiteboard?
Yes. Yes.
Okay, let me erase. The problem we are doing, I don't want to repeat because it's the same thing, was the function g piecewise, do the graph, is equal x squared is a quadratic function if x is in between -2 and +2. Anyone else see the board? Everyone see the board? Okay, Kemily Alonso is a yes. So maybe we need to wait a little bit because depending on your internet connection, maybe it's slow or no. And 2x minus 1 is, I leave the join back. Okay. If x is greater than 2. Jonathan Solano, he says, yes, I saw. Okay, the problem that we are doing in this one was this. So it was a parabola in between +2 and -2. And this point is circle full. And this is the line. This line is y equal to x minus 1. Therefore, y equal mx plus b. Y in excess -1 here, over there. And slope is 2. So it's 1, 2, and 1 here. Approximately the line look like that. Approximately here, 1, 1. Okay, the scale is no good. Okay, suppose like that. This is the line. Okay, this is the line, this line. Entonces, I need the entire, no, I need only that piece. The piece que es from 2. Pero no, wait. This circle is empty. And we continue forever in that direction. But the graph look like that. That part, circle full, circle empty, and this line. And this part, no. Erase. Okay. One way que the student using is no erase. Is put like a dotted line. Either way. Okay? Clear? Or confusing? Clear or confusing?
The coordinate was 0, -1, and then the slope was 2 over 1. Okay.
You're right. Positive. So you plot the y-intercept is 0,1, good, and slope is +2. That means that from this point you go up 1, 2 units and go to the right 1 unit. This is right, this is wrong. Super. Okay, I suppose you know that, but no, see, you don't remember, I refresh your memory. Okay, let's move on to the new topic, important topic, a complicated topic. Pay attention, please. Very, very complicated topic. Is the transformations. Okay. Transformation is complicated. You need to memorize some rule to understand transformation. Okay. Now, I try to summarize anything, and after that, I promise I put several examples, no, to understand transformation. Okay, so let me split the whiteboard in 3 parts. one column is called a function notation. Okay, another function notation. Another part is called a name of the transformation, because the transformations plural we studied have name, and you need to identification and classify and find the points. Okay, let me copy here, points. So the understanding like a points. So we have, for example, here the basic function. Remember, the basic function is a function that we studied last time, the library of the function in Euclid algebra, and the transform method, Understand the transform function. Okay. Little by little. One column, two column, and three column. Okay. The first transformation, basically we have only four. We can grouping in four transformations. Number one transformation is when you have a function, f of x, and you plus adding one number, a. I don't know, for example, the quadratic function x squared plus 2 or x squared minus 3. Now, if, for example, a is positive number, the new function is going up. Okay, with respect the basic, the original base. Okay, I promise in a few seconds you see one simulation in Desmos. Okay, clarify perfectly everything. But I want to explain transformation number one in detail, and after you see in Desmos the transformation number one, and so on. And if a is negative, like in this example, is negative 3, it's obvious that the function is going down. Okay, and the name of this is vertical shift. Because actually it's like a translation, but in the y direction, get the vertical. So in the point, the thing is more clear, in my opinion. Suppose you have x comma y, complete arbitrary point in the basic, and this is transformed. Let me use in that symbol. It's equivalent to say function like x comma y plus a. So in the vertical shift, the only thing that happens is the y value is increasing or decreasing, depending on the sign of this. So my function is going up or going down. Okay, let me show you in Desmos. Okay, I don't know if you see or not Desmos now. Let me try switching Desmos. Boom. Okay, let me try to find the example transformations. Example transformation. This transformation. Okay. Do you see Desmos or no? Answer me. Yes, no. Yes or no? Yes. Okay. I select.
Yeah.
Okay. I select the quadratic function. Get the parabola. Look, this is the parabola. Now I want to transform a little bit. I call f of x. Yeah, using every transformation here, but I know I study one by one. For example, you select here in the black color the transformation, and you move 8. When the a is positive, is going up. Okay, when the a is negative, is going down. And when the a is 0, they are perfect coincidence in between the basic and the transformer equation. Do you see or no? Do you understand? Do you understand any point, when you transform it, when you adding addition one number, the y value increasing, plus something. And when you subtract it, decreasing, go down. Subtraction. Make sense? Make sense?
Yes, yes.
Okay, super. This is easy, I know. But I promise I want to complicate a lot of your life, okay? But I try to explain step by step. Okay, do you see the whiteboard or not yet? No? Let me see whiteboard now for you. Okay, good. Do you see or no? Help me. Yes. Number 2.
Yes.
Number 2, we are doing a little bit different situation. You take the function that's given, and you adding one number, but inside the parentheses. So you affect now not the y value, you affect the x value. Entonces, when you manipulate arithmetic inside the parentheses, the effect is completely opposite to the common sense. Okay, and the y is clear, si es positive up, si es negative down. However, I want to see here, don't worry, you trust to me now. When you increasing a, si a es positive, es obvio, bueno, es obvio que the translation or the motion of the shift es horizontal. Es horizontal. Because we are changing horizontal. Horizontal. Horizontal what? Horizontal shift. The problem is in what direction. When the A is positive, you go to the left. And when it's A is negative, you go to the right. Entonces now I want to emphasize que when you manipulate inside the parenthesis, the effect is completely opposite when you manipulate outside the parenthesis. Entonces, in the point, so you have x, y, any arbitrary point in the basic function. In the transformer function, you have x, sorry, carajo. I want to call here not A, call B. To differentiate, you know. In my paper, I put B positive, B negative, you know. Entonces, x minus B, comma y. So, conclusion. Y, look at that, stay the same. Look at that, look at that. Y can stay the same. Because the motion in the transformation is horizontal. Suppose the parabola, and the parabola is moving to the right or to the left, no upward, downward, no. Therefore, the y value stays the same. However, the x value change completely opposite to the sign that you have here. So you adding a subtraction in the point, so you subtracting a addition. Let me show you in Desmos to see very well the effect. Sorry. Do you see Desmos? Only say yes, no.
Yes.
Okay. So now the transformation, bueno, in my lecture I call B, the parameter for the horizontal shift. So for example, when you put positive, look, attention now. Ooh, I move to the left. See it's negative? I move to the right. It's the only thing you need to memorize. Negative, right. Positive, left. 0, no transformation. Any question? Do you see or no? Do you see or no? Horizontal shift, vertical shift. Good. Thank you. This is a topic very, very complicated to explain for the teacher. However, I try to do my best. Okay. Okay, let's move on to the third transformation. Do you see the whiteboard? Or no?
Yes.
Okay, good. Brian. Number 3 transformation is when you have the function and you multiplication the the function by a constant I want to call C. Now this is a number 2, 3, 4, 5, or 1/2, 1/3. So we have three possibilities. Decimal is still up for me. Well, Mr. Holmes, maybe your internet have delayed, no? Let me know when you get the whiteboard. Let me check it just in case. Okay. You understand, guys? This is the just delayed of the information. Okay, focus it on the important thing. CC, que es a constant, que I multiply, D lines and leave, they come back to work for me. Okay. CC es positive. Es positive, no, es greater than 1. Si the number que you multiply is 2, 3, 4, 2.5, 10, 100, 1000, so you have like an amplification of the function. And this is called vertical. It's vertical again. But in this case, it's vertical stretch. So this is vertical stretch. Okay, because you multiply the y value. Let me try to explain here. You multiply, for example, in the point x comma y, you transform it like c, no, sorry, carajo, x comma cy. So you multiply the y value times c. Si suppose c es 2, entonces my parábola is stretching vertical. You see exactly in the decimal the effect. C is a number between 0 and 1. Entonces es compress. It's completely opposite effect. Compress. Okay. And CC is negative. Exactly negative. In general, negative. We have reflection. Reflection, but one special reflection because we have two kinds of reflection about the x-axis. Okay. This is a little bit more complicated, but no, it's no big deal. I want to show you decimals: stretch, compress. Suppose one example is stretch and multiplication by 2 or by 3. And si multiplication by 1/2, 1/3, 1/5 es compress. And si multiplication by -1, -2, entonces es reflection. Bueno, es reflection and stretch. Si es pure reflection, es negative. Pero reflection about the x-axis. Let's see in detail the third transformation is vertical, stretch, compress, and reflection. It's the technical name of this. Okay, let's see this one. Okay, there you go. Boom. Decimals again? Did you see or no?
Yes.
Okay.
Yeah.
Okay, now let's see. Suppose que C is greater than 1, because C equal 1, no transformation. Look at the difference. A, B is 0, no transformation. But C and D is 1 when there's no transformation. C equal 2 is, look at that. What is the effect? Do you see the effect? Do you understand que es vertical stretch? Entonces now, si you multiply, for example, what is the difference between the parabola x squared and the parabola 2x squared? Well, this is a little bit narrow than the original. So the original is the red one, and the transformation is the black one. So it's a little bit narrow. However, si C is less than 1, suppose 1/2. Decimal point something, 0.5. Now the new parabola is wider than the original base. So the effect is clear. However, CC is negative. specifically -1. Let me try -1. It's a perfect reflection. It's a perfect reflection about the x-axis. The x-axis behaves like a mirror, and the transforming function is the image for the region. Do you see? Do you see?
Yes. Yes.
I like this class. Everyone, student, understand very well.
So it has to be a negative for it to flip.
Absolutely. Yeah, pero no, using the technical name, please. The technical name is not flip. The technical name is reflection. What is the reason? Because we have two kinds of reflection. I don't finish the explanation. You see another kind of reflection. Okay, so the reflection is the name I want to hear, no flip. No, actually flip. Okay. The last transformation. I promise it's the last one, number 4. Now you multiply, but you multiply inside the parentheses. Multiply by a number. When you multiply, you have 3 possibilities. D is greater than 1, so 2, 3, 4, 5. B is in between 0 and 1, is equivalent to say it's a fraction, less than 1, and D is negative, less than 0. So we have horizontal. What is the reason que es horizontal? The reason because the action lie not in the y, lie in the x. The transformation is horizontal in the x-axis. Entonces when the D is 1, it's a little bit complicated to see. So it's completely opposite to this. It's complex. Now one more time happen, when you are doing the transformation inside the parenthesis, the effect is opposite to the effect outside the parenthesis. This is compressed, this is a stretch, and this is reflection. It's reflection. But reflection, let me explain a little reflection about y-axis. And this is in the effect of the point. Suppose we have a hypothetical point x, y in the basis, and the transformation is, of course, you transform the x value because you manipulate inside the parenthesis. It's x over the division because it's opposite. You are doing the multiplication in the region, and you are doing the division in the point, opposite. And why not? Why stays? Let me try to explain reflection and another reflection. Two different reflections. What is this reflection? Suppose the parabola. Suppose the parabola. This is my famous parabola. This is x squared. Suppose I introduce -1. This is my new parabola. It's up and down, negative x squared. This action, this transformation is called a vertical reflection about the x-axis. Basically is when you change the sign, the y value change the sign, and the x stays the same. However, in the horizontal reflection, one of the horizontal reflections, basically the thing that we are doing is in the function, you put a negative outside. But in this case, if you are doing reflection, in the yellow reflection, you put the negative inside. Entonces the effect is different. Let me explain, no in the parabola. You say, why not, Professor? Well, because the parabola is even function. Okay, let me explain in the square root function. They look like that. This is a square root function. So you change in the square root function, you change x for negative x, like that. My function look like that. This is the graph of the square root negative x. This is a reflection, but reflection with respect the y-axis. With respect the y-axis. In this case, reflection with respect the x-axis. When you introduce one negative outside, when you introduce one negative inside, the parenthesis is reflection with respect to the x-axis. What is the reason that I don't do the transformation in the regular parabola? Because if you introduce reflection here, this parabola, when you reflect, about the y-axis stay the same because this function is even. And when you introduce reflection, it doesn't change. Okay? Let me see en Desmos to see the last transformation que es horizontal compress, stretch or reflection. Okay. Switching over there. Do you see Desmos, right?
Yes. Yes.
Okay. Now I want to change this to 1. And also I want to switch to not this, I switching to the square root function. Boom. This is my famous square root function. By the way, the domain is positive number and the range. We have no that function in the negative, in the third quadrant, in the second quadrant, no. And thus I want to focus my attention in the transformation. Get this. Boom. You see how the original is red one, red color, and now I turn to the black color because they are perfect coincidence because we have no transformation. However, si you are doing the transformation, for example, suppose que D is greater than 1. What is the name of this effect? I need to understand the name. When the D, this is stretch or compress? What do you think? Opinion. Because
Stretch,
it's a little bit. It's what? Stretch or compress?
Stretch.
No, it's compress. Because it's horizontal compress. Look, it's you need to interpret. Oh, Dylan, yes. Look, you need to interpret. Look, okay, suppose this. This is similar. It's similar. The effect is similar. It's very, very similar. Let me try to do in opposite direction, miss. Now you see more clear. Look. D less than 1. What is this effect? This stretch or compress? This is stretch or compress? No idea.
Oh,
It's what? It's stretch. No. Yes, it's a stretch. It's a stretch. Look, this is horizontal. So you need to interpret. Suppose that you have the original red curve, and you are doing something. She moves a little bit to the right. But you know, it's like if somebody pull to the right, a modification. This is a stretch. Okay? In this case, let me try in opposite direction, and maybe you see more clearer. This is compress. Somebody push to the left. Somebody pull to the right. I know that this is very, very confusing, but you need to follow me. This is the notation, the classification that we have in our book, and that's you need to know that. Okay? Likewise, in this function, you can apply the same idea. Look. Let me show you. Suppose vertical shift. Look, upward, downward. Good. 0. Horizontal shift. Left when it's positive. Right when it's negative. Now, in the third transformation, this is stretch, vertical stretch, and vertical compress. Okay, so now, I don't forget the reflection. Look, reflection is when the D is negative 1. But reflection, the new reflection about the y-axis is like that. Oh, negative 1. Do you see the perfect reflection, the pure reflection? About the in the story. Okay. Entonces, this is theoretical part. Blah. Too much. Blah. Let's go directly to example. I prepare for you. I prepare for you example. And we can do that using decimal if you want or by hand, whatever you want. Okay. I bring the entonces now in the example. It's a little bit more complicated because you have several transformations, not only one. So we have a sequence of the transformation, and you can determine what is the order of this transformation and apply one by one. Okay, let me try. This is share. Now whiteboard. There you go. Boom, whiteboard. Do you see whiteboard?
Yes.
Super. Let me erase everything and let's move on to the first example. Example of the graphic. So what's the idea? What's the idea in the test? And the test say you start for the basic function and little by little you are doing the transformation. Suppose one function is given. F of x equal square root x plus 6 minus 5. Okay. First of all, you identification. Well, this is a family of the function square root x. Okay, this is a family of the function square root x. Now let's do it quickly and roughly after we check it out in decimals. As I know, Professor, I know the square root function look like that. Okay, so the most important point, at least 3 points. We're using 3 points. 0, 0, because the square root 0 is 0. No? 1, 1, because the square root 1 is 1, and this is 1, 2, 3, and 4. 4,2 because the square root 4 is 2. This curve represents the basic function square root x. This is my basic. Keep doing transformation one by one. You are doing now the graph of this given function. Okay. The first thing you need to understand is the order. The order is the same order of operations. Operation, remember the order of the operation, PEMDAS, parenthesis, exponent, multiplication, division, addition, subtraction. And when you're talking about parenthesis, it's all the grouping symbol. Grouping symbol, you understand que es el paréntesis, el bracket, pero es also absolute value or it's also radical. Radical es considered like a parenthesis. O sea, this radical, actually it's a radical, but you can consider it like a parenthesis, a grouping symbol. But the operation inside the grouping symbol is the higher priority. And plus 6 is equivalent to say, look. This is f of x, but this is f of x is the original. So I propose you do this transformation, x plus 6. Okay, just replace x for no x anymore, it's x plus 6. It's this idea. Okay? So I know that my new graph is exactly like that. No, not exactly. The same shape, no compression, no transformation, no stretching, no. But it's moving 6 units to the left. Yes or no? At this point, this famous point, gets the point 0, 0, actually now is -1, -2, -3, -4, -5, -6, -6, 0. Okay, that means that our curve start here, not in 0, 0, sino in -6, 0, and open exactly the same like that. Wait, Professor. What's going on with that point get 1, 1? When you see it moving 6 units to the left, it's because the x component get 1 is now 5. So at that point is the point -5, 1. Okay, do you see how the y component change? However, the x component no stay the same. And this point is 4, -6 is -2. And -2 I'm supposed to here And that point is the point -2, 2. Do you understand this? There's a classification, the name of this transformation. Oh, well, this is horizontal. I'm sorry, professor. Why -6? Because it's to the left. Because it's to the left. Dylan? I explained before. Oh, okay. Okay, this is
-2.
Say again.
The -2.
-2 come from 4. Look. The list of the point is 0,0, 1,1, and 4,2. When you are doing this transformation, boom, this point is become -6,0. Why, professor? Well, because you're subtracting 6 in any x component, and the y component stays the same. The second guy is -5,1, and the rest is 4 minus 6 is -2, 2. Do you see or no?
Yes.
Clifford?
Yes.
Okay. Are we finished? No, we don't. I need to do the last transformation. The last transformation is this is, well, okay, sorry. This is the horizontal shift, no? Horizontal shift. 6 units to the left. How do you know which left? Because it's positive. Okay, now the last transformation is f of x plus 6 minus 5. Minus 5 is vertical shift. This is vertical shift 5 unit down. 5 unit down. Okay. So actually, my final answer after the 2 transformation was, okay, this point now is -6,0 is transformed according to the second transformation, that is -5, like a -6, -5. Because in this transformation, you subtracting 5 in the y component, x, y. The x stays the same because it's vertical, and the y, no, subtract. This point is the point -5,1 should be -5, -4. Because 1 minus 5 is -4, no? And the last point is -2, +2. After the transformation, when you subtracting 5 in the y component, is -2, -3. Because it's 2 minus 5, no? 2 minus 5, 2 minus 5, and negative. And you see that the x component stays the same. Okay, let me try to do my best. The point is 6, -5, so it's, wow. -1, 2, 3, 4, 5, 6, -6, -5, 1, 2, 3, 4, 5. Okay, that point. At that point is transformed in that point. Is this? That point is transformed in -5, -4. Something like that. And that point is transformed in that point, -2. Here, over there, -3, -1, -2, -2. Now you're connecting. You know, in this case, doesn't affect the shape. The shape doesn't affect. It's the same shape, but the position, the location is changing. So we are doing, first of all, a horizontal shift, 6 units to the left, moving to the left, 6 units, and after we move it down, 5 units down. Vertical shift. End the story. You see or not? Okay, I want to show you this.
Can you do that? Lost your cursor.
The last one. Okay. The last one is subtracting 5. It's the transformation that I can see. This is the transformation. I highlight in yellow. Subtracting 5 outside the parentheses means that you change the y value of the point minus 5. But this is my original. This is my original. Look, 0. No original, but after the transformation 1. This is transformation 1, and this is transformation 2, no? We have 2 transformations, and sometimes we have 3 transformations. But don't worry, step by step. So you subtracting 5 in any y component in this. 0 minus 5 minus 5. 1 minus 5 minus 4. 2 minus 5 is negative. And you plot that point, it's exactly I did, and you connect it by the curve. To represent this last, okay, this curve is radical x. This curve is radical x plus 6. And this curve is radical x plus 6 minus 5. More clear? More clear?
Yes.
Super. Okay, let's move on to the decimals. Okay, I don't want working with the paper. The paper I don't like. I want in decimals. I need to train into you in decimals. Now you are strong when you take pre-calculus. Okay? Let's move on to decimals to see example. I prepare for you. Okay, let me try. Switching to decimals. Okay, boom, boom. Okay, this is another folder. Is example of transformation. Do you see decimals?
Yes.
Good. Let's move on to example 1. Look, example 1 is example that we did before. It's radical x. I put inside the folder. Radical x plus 6 minus 5. Let's move on. Boom. Okay, look at that. In the blue curve is the basic function before any transformation. In this case, we are doing look. Square root x plus 6 minus 5. So we are doing a horizontal shift, 6 units to the left, and after 5 units, vertical shift, sorry, 5 units down. If you want, you can see step by step. Let me show you step by step. Suppose I delete that part. Boom, boom. It's only horizontal shift. Using another line, I want to copy this. Highlight, select, Control C, Control V. So you want to see the process step by step. Outside the radical, you put minus 5, minus 5. Boom. And what is my final answer? Oh no, my final answer, professor, is the red one. Okay, the original is the blue. One partial intermediate answer is the green. After the transformation number 1, and after the transformation number 2, boom, is the do you see more clear now? Come on, I need to know. Come on, guy, help me. Okay, yes, Dylan is the only guy can help me.
You broke it down and down.
Broke it down, yeah. I separate piece by piece, transformation by transformation. Let me try another more complicated example, and you help me to understand this. Okay, we have 5 minutes. We are doing something. I promise we continue next time doing transformation and the last part. You can see in the syllabus. I don't remember now what is the date for the test, but don't worry. You know that the test is coming after the review. It's a signal. Okay, now suppose this example. Let me see if you see or no the whiteboard now. Boom, boom, boom. So I am doing it a little bit easier. I don't want to do it step by step. No. I give you the example 2. You identification, the transformation, and after we are doing everything in decimal. Look at that. The function is f of x is equal minus x minus 5 squared plus 3. Okay, my first question is, what is the basic function associate with this example? No. Dylan, my question is, what is the basic function? So you have a library, a collection of the function. Constant function, linear function, quadratic function, square root function, cubic root function, blah, 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 absolute value. What is the function? Identification. What is the mother in this collection, in this family? What is the mother? The basic function. Huh? Come on. Do you understand what I asked you? Okay, we start for the one basic. And doing transformation, we will obtain a family of the functions. But what's the mother in this family? No?
X minus 5 squared.
Say again. Quadratic. Very well, Clifford. Quadratic. Is f of x is this. This is the basic. This is the basic. I know. I know que the next derivate for this. But we have several sequence of transformation. Transformation number one. What do you think is the transformation number one? Help me, identification transformation. Remember that we analyze according to the order of operations. And what is the first operation that you should do? Huh? Okay, it's like that. Look, f x minus 5. Yes or no? So when you plug in one number here, the first thing you should do is subtract the 5. Well, no, after the square, of course, because this is implicit in my basic function. So this is fx minus y. Do you understand what is the reason? It's very, very useful. The function notation to understand the thing in mathematics and algebra. So now, this transformation, what is the name of this transformation? What is the name? What is the name? This shift, compression, reflection. What is that? Hey, are you there? You're leaving. Horizontal shift. Very well. Dylan say horizontal shift. In what direction, Dylan? Left or right? Horizontal shift. Click for the same. Horizontal shift, professor. Okay, good. In what direction? Right or left? Huh? HT. What does it mean HT? Horizontal. Horizontal transformation. But in what direction? Right. Very well. How do you not get right? Because it's negative 5. When it's negative, it's right. Okay. So basically, look at that. This is my parabola. You know, that the basic function quadratic look like that. And by nu is no in 0, 0. No. It's in 5, 0. 1, 2, 3, 4, 5, comma 0. Like that. Same shape, but we move 5 units to the right. This is a typical horizontal shift. Well, I did that. Horizontal shift. Everyone follow me? Oh no? Totally lost? Okay, so we have transformation 2. What is the second transformation that you see? Be careful. So remember, the thing is, I plug in one number here. Plugging in. Subtracting 5, square. Now change the sign. This minus. And this minus is like. You are doing this transformation. And you put the negative here. What is that? What is the transformation of this? Name. What is the transformation of this? When you put a negative outside. Negative 1. Huh? Help me, guy. with negative sign. It's what?
Reflection.
Reflection. No vertical shift, no. Reflection. Pero reflection in what direction? In the X direction or the Y direction? X direction or Y direction? X direction or Y direction? Come on, guys, the time is over. X direction. X. So now our graph, I promise again that next time we are redo again this example. So now this is my parabola right now. The point this stays the same, 5,0, but my new parabola is going down. Reflection about the x-axis. Finally, plus 3. Transformation number 3 is minus fx minus 5 plus 3. This plus 3, what is that? Is vertical shift. 3 units up. Okay? So my parabola definitely, finally, is in this point, but no 5,0, it's 5,3. 1, 2, 3. Look like that. That point, 5,3. So that point, it was our reference to understand the transformation. At the beginning, in the basic, is 0,0. And the first transformation was transformed 5,0 because was horizontal shift 5 units to the right. After we introduce a negative, and this negative give me reflection, but the point stays the same. But the parabola no, the parabola up and down. Now finally plus 3 is vertical shift 3 units up. Therefore my parabola is moving, totally my parabola is moving on 3 units up. Okay guys, too much for today. Okay. As always, I recommend that you continue doing homework. The homework is extremely important. Any doubt, any question that you have,